Oxygen gas and magnesium react to form 2.43 gram of magnesium oxide. What volume of oxygen gas at 94.9 kilopascal and 25.0 degrees Celsius would be consumed to produce this mass of magnesium oxide? Now there are 4 steps to solve this problem. Step 1 is to write a balanced chemical equation. Step 2 is to convert 2.43 grams of magnesium oxide to moles of magnesium oxide. Step 3 is to determine the moles of oxygen consumed. And step 4 is, using the ideal gas equation, determine the volume of oxygen gas. Now step 1, write a balanced chemical equation. Now the balanced chemical equation is 2 moles of magnesium reacts with 1 mole of oxygen to produce 2 moles of magnesium oxide. Step 2. Convert 2.43 grams of magnesium oxide to moles of magnesium oxide. Now we need to use the periodic table to determine the molar mass of magnesium oxide. And using the periodic table, the relative atomic mass of magnesium is 24.31 and the relative atomic mass of oxygen is 16.00. So the molar mass of magnesium oxide equals 24.31 plus 16.00 equals 40.31 grams per mole. Now in order to convert 2.43 grams of magnesium oxide to moles of magnesium oxide, we need to use a proportion consisting of ratios of grams of magnesium oxide to moles of magnesium oxide. And our first ratio should consist of known values. So the known values are 40.31 grams per mole of magnesium oxide equals 2.43 grams of magnesium oxide divided by X, where X represent the moles of magnesium oxide corresponding to 2.43 grams of magnesium oxide. Now we need to use cross multiplication to determine the value of X. So X times 40.31 equals 1 times 2.43. 40.31x equals 2.43. Therefore, x equals 2.43 divided by 40.31. Therefore, x equals 0.06. Hence, 0.06 moles of magnesium oxide are produced. Step 3 is to determine moles of oxygen consumed. We need to use a proportion consisting of ratios of moles of magnesium oxide to moles of oxygen. Our first ratio should consist of known values, which we can get from the balanced chemical equation. From the balanced chemical equation, we can see that 1 mole of oxygen produces 2 moles of magnesium oxide. So our first ratio will be moles of magnesium oxide, which is 2, divided by moles of oxygen, which is 1, equals moles of magnesium oxide, which we have calculated in the previous step, 0.06, divided by X, the moles of oxygen. Now we need to cross multiply to determine the moles of oxygen. So 2 times X equals 0.060 times 1. 2x equals 0.060. X equals 0.060 divided by 2. Therefore, x equals 0.030. Hence, 0.030 moles of oxygen are consumed. Step 4. Using the ideal gas equation, determine the volume of oxygen consumed. Now the ideal gas equation is PV equals nRT. Now since we have to determine the volume of oxygen consumed, we need to rearrange the formula to determine the volume of oxygen consumed. And the rearranged formula is V equals nRT divided by P. And substituting values, V equals N, which is the moles of oxygen, and we have calculated this value in the previous step, in step 3. So from step 3 you can see that 0.030 moles of oxygen is consumed. Therefore V equals 0.030 times R, which is a universal constant and it's equal to 8.314, times the temperature in Kelvin. Now, from the question, the temperature is 25 degrees Celsius. Now, to convert 25 degrees Celsius to Kelvin, we need to add 273. Then we divide this value by the pressure, which is also given in the question, and the pressure is 94.9 kilopascals. So we need to divide this by 94.9. So the volume equals 0.030 times 8.314 times 273 plus 25, which is 298, divided by 94.9. And using your calculator, you will find out that this value is 0.78. Hence, 0.78 liters of oxygen gas would be consumed to produce 2.43 grams of magnesium oxide.